Students, in this session, we are going to see about the factors on which the resistance of the conductor depends. This is a simple circuit which is used to find the factors on which the resistance depends. So, this is a circuit contains a battery with the ammeter connected in series, and there is a opening X and Y. In between the opening X and Y only, we are going to connect the nichrome wire, and the end will be connected with key, and the circuit will be closed. This nichrome wire has a length L and the area of cross section A. So whenever there is a change in the length and the area of there is a any change in dimension, the length or area, there will be a change in the current reading. So that will be noted down in the ammeter. So we are going to find the relation between the dimensional change with the current change, and hence we are going to find what is the relation with the resistance of the material. This is a simple tabulation which shows very clearly the nichrome wire of the length L and the area of cross section is connected to the in between the terminals X and Y. So what is the length means we know that, but area means what is the area of cross section? Area of cross section means it is merely a thickness of the wire. First we will connect the nichrome wire of length L and the area of cross section A. So this will be connected means we should note down the ammeter reading. So it shows some current value I and the resistance value we have to calculate. How we can calculate the resistance value? By knowing this current value and the battery connector, this voltage value, merely substitute in this formula R is equal to V by I. We are able to calculate the resistance of the connected nichrome wire. Next, we are going to connect the nichrome wire of the length 2 times than that of the previous one, and we will observe that the ammeter reading will, that is the current value is decreases than that of the previous one. When the length remains same but the area of cross section only doubled means the ammeter reading shows, that is a current value shows it is increases, current will be increases. If the nichrome wire is removed and the copper wire is connected with the length L and the area of cross section A, it is evidently we see that the current and current value is entirely different from the nichrome wire. So we will see that whenever there is a current decreases, the resistance increases, because the resistance and the current will be inversely proportional. Hence when the current value decreases, resistance value increases for when the length increases. If the area of cross section is doubled, the current value increases, correspondingly the resistance value decreases. So by this in this table we are able to find that the resistance is proportional to length and the resistance is proportional to area of cross section, and the resistance also depends upon the material. When the material, instead of the nichrome wire, if the copper wire is connected, the resistance of this copper wire is entirely different value from the nichrome wire. Both are not equal. So we come to the conclusion. The resistance of the wire is directly proportional to length of the wire, and the resistance is inversely proportional to area of cross section. So R is equal to rho, that is R is directly proportional to L by A. That is, in order to remove this proportionality, we put a constant is called as a resistivity. Resistivity symbol is rho. So RHO. So the resistivity is equal to resistivity is equal to the characteristic property of the material. So what is the SI unit of the resistivity? So we can calculate by using the formula R is equal to rho L by A. By using this formula R is equal to rho L by A, keep this rho as it's the same side, bring the area and the length in the left side, we get the equation R is equal to rho L by A. So whenever the SI unit is you are going to calculate means you may derive the SI unit from the formula itself. So that is rho is equal to R A by L. R is a ohm, that is a resistance, SI unit is ohm, and the area of cross section is meter squared, and the length is meter. So the meter get cancelled, we get the resistivity SI unit is equal to ohm meter, or in symbol we can write like this. Finally we come to the conclusion. What are all the factors? It depends. It is a 4 factors. So you know that length, area and resistivity resistivity. Resistivity means material dependence. When each and every material has different resistivity. That's why all the different wire has different resistance value. Here we are writing that length of the wire and area of the cross section and material, and the fourth important factor is temperature. Why we are include the temperature? Whenever there is an increase in temperature, change in temperature, the electron vibration, the thermal vibration may be increased. Due to this thermal vibration, the motion of the free electrons will be disturbed, and hence the resistance value will be changed. So when the temperature increase, resistance increase. That is, the resistance and the temperature are directly proportional for metals. So very important, it is only for the metals. Now we are going to see some exam point of view formulas. So the length is L and area of cross section is A, means the resistance formula is R is equal to rho L by A. If you increase double the length, means area of cross section remains same, but the length alone doubled, means in this formula the resistance value is not equal, so I will put the R prime. So rho as it is, instead of L we have to substitute 2L, then area of cross section remains same, so as it is A, we get the answer 2 into rho L by A. So rho L by A is equal to the original resistance, so the new resistance is 2 times of the original resistance. So when the length of the wire is remains same, the area of cross section, that means the thickness of the wire only increased, doubled means, so you substitute the value, that is instead of area you have to substitute 2A, we get the answer 1 by 2. That is, the new resistance will be half the time of the original resistance of the wire. If we take the wire, that wire length is decreased, wire length is halved, that is L by 2 means, but very important, here I will change only here the length alone, here the area of cross section alone, here the length alone, so not change in the another dimension. So length alone halved means, substitute in the formula, we get the answer, the new resistance is half of the original resistance. In the similar way, we get that the thickness is halved, the area of cross section is halved, we get the new resistance is equal to 2R, that is double the time of the original resistance. Students, please clearly observe the formulas. This may be useful for your examination point of view. The another important question is, sometimes in examination they will ask that the given length of the wire is stretched to doubled. So find the change in the resistance. Find the new resistance of the wire. So what is original resistance? R is equal to rho L by A. This is the length L and areas. In that question it is given that the wire is stretched to double of its length. So that means the new resistance in the wire is stretched to double of its length, the length is doubled. Then what about the area of cross section? It is halved. So you imagine that if it is a thick wire, so if the length of the wire is increased, means what will happen? The thickness will be reduced. We are often seen in that if you stretch some wire, means we are able to observe this point. So as we see earlier, when the length is doubled, means area is not changed. In the question itself it is given. For in this question it is simply given the given length of the wire is stretched to double, means always the length is doubled. Correspondingly the area of cross section will be halved. So you have to take this consideration also. Then you substitute in the formula, length is equal to 2L and the area of cross section is equal to A by 2. We get the new resistance. What is the final resistance of the stretched wire is 4 times of its original resistance. Also I will give you one work, that is area of cross section is doubled, A is doubled, and what about the length? If the area of cross section is doubled, means what will happen? Length will be halved. Very simple. This is the length of the wire of length L and the area of cross section A. If it is doubled, means the length will be halved. The length will become L by 2 and the area of cross section become 2A. That is, it is given. I am writing here the same way. So what is the new resistance? The length will become L by 2. So what is the new resistance? R prime, which is equal to rho L is equal to L by 2 and A is equal to 2A. So finally we get the answer 1 by 4 R. that is new resistance is 1/4 of the original resistance. So these are all the points you have to keep in your mind for exam point of view very clearly. So then this is a very important question that is often repeatedly asked in the board examination. Why alloys are commonly used in electrical heating devices? This is because the resistivity of the alloy is generally higher than that of the individual constituent metal. Let us take the metal A and metal B are combined together to form a alloy AB. Though metal A has a resistivity ρ1 and metal B has a resistivity ρ2, so if we combine together it will become a new material, alloy material. So this alloy material resistivity is ρ. This resistivity is always greater than this individual metal resistivities ρ1 and ρ2. Then the second point is alloys do not oxidize readily at high temperature. That means it has a high melting point. Yes, we summarize the points. So what are all the factors? It depends upon the factors of length, area of cross section, material and temperature. So the resistance of the material depends upon these 4 factors. When these 4 factors are changed, the resistance of the material also changed. So what is resistance? The resistance means it is a resistance which resists the flow of charges, that is which opposes the flow of charges. That thing you have to keep in your mind.